Hello students, in the previous videos we find the Cartesian product of any two sets. That is, if the sets are given, how to find the Cartesian product. And also in reverse, suppose the Cartesian product is given, how to find the individual sets is the first step. And second one, how to find the union, intersection and difference of a sets. That is, the sets are given, suppose to find a union, intersection and difference. How to find is the second one. And the third one, how to find the Cartesian product of a union, intersection and also set difference. Among all the problem we already see in the previous videos. Now today we see the same model questions, but the sum is a very big. It's a 5 more question. So a lot of order pair will come. So don't panic. It's also very easy. We do one by one step. Okay, the sum is the value of A is x belongs to W such that x is less than 2. You know the set builder form. Now the first step to convert the given set in a number or roster form. It is easy to write the Cartesian product. You see the first two sets are indirectly given and the third set C is directly given the letters 3, 5. So the first step to convert the first two sets in a roster form. So how to write? Given the set A is consist of all the element is x, where x belongs to W. W means the set of all whole numbers. All the whole number is always start from. It is 0. So x belongs to W and also x satisfies one condition, the value of x is less than 2. Okay, the value of x is also less than 2. So what is the first possible number? The first possible number is 0 and 1. So these two number only possible because the whole number start from 0 and also the value of x is less than 2. So the two number only possible, the numbers are 0 and 1. So it is a value of the set A. In the same manner, next to find the another set B. Now we identify what is the values of B. B contains all elements are x, where x is a natural number. Is x belongs to n, capital N denote the set of natural number. And also this x satisfies one condition, 1 less than x less than or is equal to 4. That means the value of x is more than 1 and also it should be less than or is equal to 4. So what is the possible numbers this contains in the set B? Do you identify? What is the first number? The first number is 2 because the number 2 is greater than 1 and the next number is 3. Here 4 is also possible because the value of x is less than or is equal to 4. So 4 is also possible. So it is a value of the set B. And the third one, the set C is directly given in roster form. The value is 3, 5. So it is the first step to find the Cartesian of any given sums. Suppose the given set is not given in the roster form, to convert first of all in a roster form, that is in number or letters form. It is easily to convert the Cartesian product of any two sets. So what is the next step? First step, we find all are in roster form. Next, to verify A cross B intersection C, it should be is equal to A cross B intersection A cross C. In all verification, first we need the value of LHS. What is the value of LHS here? That is left hand side. What is the value of left hand side? Is A cross B intersection C. We already find the set A value. Okay, it's a 0, 1. The next step to find the value of B intersection C, because we have the individual sets B and C only. We don't know have the value of B intersection C. So the first work to find the value of B intersection C. So B intersection C. You know the concept of intersection. Intersection means common. the element is common in both the set B and C. You see the set B and C. What are the elements is common in B and C? What are the elements are common? The only one element, the element is 3. So the element 3 only common in both B and C. So B intersection C contains how many elements? That is only one element. The element is, yes, it is 3. So B intersection C contains only one element. The element is 3. So now we find the Cartesian product of A cross B intersection C. Now we find the Cartesian product of the set A and another set B intersection C. What are the values of A is given? The value of A, we already find that value is 0, 1. Cross product with the B intersection C. What is the value of B intersection C? That value is only one element, 3. Do you remember how to find the Cartesian product of any two sets? What is the working rule? To write all possible ordered pair. The first element occur in the first set and the second element occur in the second set. So what is the first possible order pair? The first possible order pair is 0, 3. 0 lies in the first set, this 3 lies in the second set. Is the first possible order pair. But in the second set it contains only one element. So 0, 3 is over. What is the next possible order pair? Here one more element is there in the first set. So we move, after 0 we get 1. So another order pair value is this 1, 3. 1, 3. Over it is a value of the LHS. Okay, A cross B intersection C value. Now to check, the same order pair value will also come in RHS. So now we will take RHS. Right hand side. What is the value of the right hand side? Is A cross B intersection of A cross C. If we find A cross B intersection A cross C, first we find the Cartesian product of A cross B, because we need the intersection of these two sets. So first we find the unknown sets. So what are the unknown sets? One is A cross B and another one is A cross C. So the first work to find A cross B. A cross B. What are the elements of A? Is 0, 1. Cross, what is the next set? B. The value of the set B is 2, 3, 4. So now to find the Cartesian product of these two sets, so A cross B. Now to write all possible ordered pair. Okay, we do the same work. What is the first work? 0, 2. The next possible order pair is 0, 3. Next one 0, 4. That is, we don't change the element in the first set and we move the element in the second set. So we do this way, there is no repetition will occur. So is a working rule. 0, 2, 0, 3, 0, 4. What is the next possible order pair? We are moving the element in the first set, we do the same work. So the next possible order pair is 1, 2. 1, 2. Next one 1, 3. The last possible order pair is 1, 4. So to write all possible order pair, it is a value of A cross B. Next we find the Cartesian product of A and C, A cross C. Again we write the elements of A. The elements of A are 0, 1. Cross. The next set is C. What is the element C? There will be two elements. The elements are 3, 5. Now to find the Cartesian product of these two sets. The first possible order pair is 0 comma S 3. So 0 comma 3. Next one 0 comma 5. First element over. Now we move the second element 1. So 1 comma 3. Then 1 comma 5. So it is a value of A cross C. Now we find first these two Cartesian product A cross B and A cross C. Now we find the intersection of these two sets. So the first one is A cross B, intersection of A cross C. You know how to find the intersection. Intersection means a common. So what are the common order pair in A cross B and A cross C? I take the common ordered pair. You see 0 comma 2 lies in A cross B, but in A cross C 0 comma 2 is not there. So 0 comma 3 is the second one. Here also 0 comma 3. Next, you identify anyone is common in both the sets. We check. Yes, the another one is 1 comma 3. Other than these two ordered pair, anyone is common in both. For example, I will be take 1 comma 2 in A cross B. 1 comma 2. You see the order pair 1 comma 2 lies in A cross C? Is not there. And another one, suppose I will be take 1 comma 5 in A cross C. 1 comma 5. You see the order pair lies in A cross B? Is not there. So only two order pair is possible. They are 0 comma 3 and 1 comma 3. So this is the value of A cross B intersection of A cross C. Now I put it is a second equation. Now you see from 1 and 2. In first equation also there will be these two sides 0 comma 3 1 comma 3. You see here 0 comma 3 1 comma 3. And the second equation also contains the same number of ordered pair and also the elements are same. So what is the conclusion? From 1 and 2 both LHS and RHS both are equal. Therefore the given one is verified. From 1 and 2, from 1 and 2, the conclusion is very important. We must write the conclusion because it is a proof sum. What we identify from the equation 1 and 2, we check both the LHS and RHS both are equal. So we must write LHS and RHS both are is the same number of ordered pair. So LHS and RHS both are equal. Therefore A cross B intersection C value, that is it is a value of LHS, is equal to the RHS. What is RHS? A cross B intersection of A cross C is verified. Suppose LHS and RHS both are is not is equal. How to verify? We can't verify. So how to write the conclusion? So we come to the conclusion, suppose both are is not equal, in a create a sum, is a verify sum, LHS and RHS is not equal. The conclusion is from 1 and 2 LHS is not is equal to RHS and the given statement is not verified. So it is a conclusion. Suppose LHS and RHS both have the different values, but in most of you in our book sum all are in verification sum, but in the examination point of view 1 or 2 sum is given in a created model. In our 1 or 2 sum LHS and RHS it may not be equal. So how to the conclusion? 1 and 2 the given one is not verified, or the first LHS is not is equal to the RHS. That's subdivision. The same question, but we verify the different one. Is A union B cross C is equal to A cross C union of B cross C. The sets are same A, B and C, but the another type of a Cartesian product. What is the first step? To convert the sets in roster form. Now you tell the answer. What is the value of A? You know very well. What is the value of A? The value of A is 0 comma 1. What is the value of b? The value of b is, b contains all are natural number. The first natural number is 1, but x satisfies one more condition, 1 less than x less than or equal to 4. So the value of x, it should be more than 1 or greater than 1. The greater than 1 of the natural number is 2. So 2, 3, 4 is also possible because the value of x is less than or is equal to 4. So 4. And the set C is directly given in roster form. The value is 3 comma 5. So the first step, to convert all the given sets in the number or letter form, that is called the roster form. Okay, the 3 sets. Now, what is the value of LHS? The value of LHS is A union B cross C. A union B cross C. If we find A union B cross C, first of all we need the individual sets. Here A union B cross C. C sets okay. A union B. A set and B set you know very well, but in individual. So our first work is to find the union of these two sets. So first we find A union B. You know the working rule how to find the union of any two sets. What is the working rule to find the union of any two sets? All the elements occur in A or in B, but the repetition is not allowed. And also we write the number or letter in alphabet order. In number, it is in ascending order. Suppose it is in letter, we write in alphabet order. But here all are numbers. A union B. So we see the sets A and B. A and B. And also union. So we mingle both the sets. In all the number, what is the least number? The least number is 0. So first we write is 0. The next number is 1. And then 0, 1 over. In B, 2, 3, 4. So no one element is occur in A. Therefore 2, 3, 4. 2 comma 3 comma 4. So these are the values of A union B. Suppose A intersection B is given. What is the value of A intersection B? Identify. Intersection means common. What is the common element in A and B? No one is common. In A and B, no one is common. So what is the value of A intersection B? No one is common, it is empty set. Okay. What is the symbol of the empty set? Is a pi or an empty set. Suppose the question will be asked in intersection, it is an empty set. But our question will be asked in A union B. So A union B value is, it contains this 5 elements. So the next step, the Cartesian product of these two sets. So we write first A union B cross. What is the next set? C. So first we write the elements of A union B. The elements of A union B is start from 0 up to 4. 0 comma 1 comma 2 comma 3 comma 4. 0 1 2 3 4 cross. The next set is C. What is the element contained in the set C? 3 comma 5. 3 comma 5. Now to find the Cartesian product of these two, A union B cross C is a value of A union B cross 3 comma 5 is a value of C. Now we find the Cartesian product of these two sets. So many ordered pair is there. You don't leave any one of the ordered pair. It's an easy way. What is the working rule? Always in the ordered pair, the first element lies in the first set and the second element lies in the second set. Okay. So what is the first possible ordered pair? The first possible ordered pair is, yes, you tell the answer, 0 comma 3. Yes, 0 ,, here 3 is the first one. 0 , 1 , 2 , 3 , 4 , 5 , 6 , 7 , 8 , 9 , 10 , 11 , 12 , 13 , 14 , 15 , 16 , 17 , 18 , 19 , 20 , 21 , 22 , 23 , 24 , 25 , 26 , 27 , 28 , 29 , 30 , 31 , 32 , 33 , 34 , 35 , 36 , 37 , 38 , 39 , 40 , 41 , 42 , 43 , 44 , 45 , 46 , 47 , 48 , 49 , 50 , 51 , 52 , 53 , 54 , 55 , 56 , 57 , 58 , 59 , 60 , 61 , 62 , 63 , 64 , 65 , 66 , 67 , 68 , 69 , 70 , 71 , 72 , 73 , 74 , 75 , 76 , 77 , 78 , 79 , 80 , 81 , 82 , 83 , 84 , 85 , 86 , 87 , 88 , 89 , 90 , 91 , 92 , And the second one is don't change element in the first set, we change the element in the second set. After 3 in the second set is 5, so 0 comma 5. Wow. The next one, we change the element in the first set, so after 0 the next element is 1, we do the same process. So next order pair is 1 comma 3, 1 comma 5. The next one, after 1 the next element is 2, 2 comma 3, 2 comma 5. The next one, after 2 the next number is 3, so we write it is 3 comma 3, 3 comma 5. You tell the remaining 2 order pair, 2 remaining order pair is the, do you identify? They are 4 comma 3 and 4 comma 5. So 4 comma 3 and 4 comma 5. Actually it is a value of LHS, it is a left hand side. So it contains so many order pair. For in your convention you count the number of order pair. How many order pair is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same number of ordered pair and also the elements of ordered pair, suppose all are equal, then LHS and RHS are equal. So now to check the right hand side value. RHS. What is the value of RHS? A cross C union of B cross C. That is to find the union of these two sets. If we find the union of these two sets, first we find the individual sets. That is to find A cross C first and then B cross C. Then we mingled A cross C and B cross C. So first we find the Cartesian product of A and C. A cross C. What are the elements contained in A? The elements contained in A is 0 comma 1 cross C. What are the elements contained in C? Is 3 comma 5. Now we write the Cartesian product of these two sets. The first possible order pair is 0 comma 3. Okay, 0 comma 3. The next one 0 comma 5. Yes. Okay, the next order pair is 1 comma 3. The next one is 1 comma 5. So they are the values of A cross C. Next we find, yes, it is B cross C. B cross C. What are the elements of B? The element of B is 2, 3, 4 cross 2, 3, 4 cross C. The element of C is 3 comma 5. Now we write the Cartesian product of these two sets. Do you identify what is the first possible order pair? That is 2 comma 3. Do you identify what is the last possible order pair? The last possible order pair is 4 comma 5. So we write one by one. 2 comma 3. Okay, 2 comma 3. The next one 2 comma 5. Okay, we moving 3 comma 3. Then 3 comma 5. Next one 4 comma 3. Last one 4 comma 5. So it is a value of B cross C. Now we write A cross C union of B cross C. Okay, now we mingle A cross C and B cross C. It's a value of A cross C and it is a value of B cross C. Union. Union means the element occur in either the first set or in second set, but the repetition is not allowed. Okay. we write in the ascending order, that is in an ordered pair. We start from a 0, 1, 2, 3 like this. Okay, the least is 0, 3. So first I write 0, 3, 0, 5. Now I check in B cross C, any one of the ordered pair is start from 0, so no one is there. So after 0 the next number is 1, so 1, 3, 1, 5. Okay, wow, I write all the elements in A cross C. Next we see the element in B cross C, so no one is common here, so you write continuously of B cross C because already in ascending order 2, 3 and 4. So the next order pair is 2, 3. Next one 2, 5, 3, 3, 3, 5, 4, 3, 4, 5. I put it is the second equation. Now we check from 1 and 2, both are in the same number of ordered pair and also equal number of ordered pair. I check, the first one is ordered pair is 0, 3 is also there, 0, 5, 1, 3, 1, 5, 2, 3, then 2, 5, 3, 3, 3, 5, 4, 3, 4, 5. So from 1 and 2 both they contain the 10 number of ordered pair and also important all the ordered pair the same elements. Okay, so 1 and 2 both are in the same number of ordered pair. What is the conclusion? The conclusion is from 1 and 2. How to write the conclusion? From 1 and 2, LHS and RHS both are equal, therefore the given statement is verified. A, B and C all are given in word problem. Okay, all are given in the word. So the first step to convert all the set in poster form. You see A, B and C. What is the value of A? A contains set of natural numbers, all are natural number, and also it satisfies one more condition, it is a less than 8. What is the first natural number? Is 1. So we write the number start from 1 up to, yes, it is 7 because the natural number is less than 8. So the possible values of the set A is, we start all natural number, the natural number start from 1, next 2, 3, 4, 5, 6 and 7. I stop 7 because the natural number is less than 8, so 7. So the set A contains 7 elements. Next one, B. How to define B? B define the set of prime numbers. We write collect prime number and also the prime number is less than 8. In the previous video we already explained what is meant by a prime number. A prime number is a number which is divisible by 1 and by itself. Okay, what is the first prime number? That is 2, then 3, 5. We write all prime number up to less than 8, then 7. So these are the prime number is less than 8. So B contains 4 elements, 2, 3, 5 and 7. And how to define a C? C, the set of A1 prime number. You already know in the lower class, you know only one A1 prime number. That is all the prime numbers are odd except one number. The number is, yes, it is 2. So 2 is the only A1 prime number. So the set C contains just one element, but A contains 7 elements and B contains 4 elements. So the first step to find the individual sets A, B and C. Okay, in a stage mark we find correctly A, B and C, we credit 1 marks. In a 5 mark question is the first step to, there is no mistake in your answer sheet, the 1 mark will be allotted. The next step to find LHS. What is the LHS? Is A intersection B. Okay, A intersection B cross C. That is, to find the Cartesian product of A intersection B and C, we know the set C value is only 2. So we find the intersection of these two sets, okay, A and B. So the first working rule is to find A intersection B. You know the working rule of intersection. Intersection means a common. So what are the elements are common in A and B? In A and B, what are the elements are common? The first number is, yes, 2, then 3, 5, 7. So these are the elements are common in A and B. So 2, 3, 5 and 7. So this is the values of A intersection B. Now we find A intersection B cross C. The value of A intersection B is 2, 3, 5, 7 cross C. The set C contains only one element, the element is 2. Now we find the cross product or the Cartesian product of these two sets. So first possible order pair is 2, 2, 2, 2. But in the second set is not the another element, it contains only one element. So first possible order pair is 2, 2. What is the next possible order pair? Yes, the second set contains no element, so we moving the element in the first set. So the next one is 3, 2. Okay, the next one 5, 2, and the last one is 7, 2. So these are the values of LHS. It is a value of A intersection B cross C. Now we check the same value will come in the RHS also. Now we will move RHS. What is the value of RHS? The value of RHS is A cross C intersection of B cross C. If we need the intersection of these two sets, first we find the set A cross C and B cross C. So the first step to find A cross C. So A, the set A contains the elements start from 1 to 7. 1, 2, 3, 4, 5, 6, 7. Cross C, the set C contain only one element, that element is 2. Now we write the ordered pair. Okay, in the previous also the second set contains only one element. How to find the ordered pair? What is the first possible ordered pair? Is a 1, 2. Next one 2, 2. 3, 2. Okay, next 4, 2. Then 5, 2. Next element 6, 2. And the last element is 7, 2. So these are the ordered pair of A cross C. Next we find B cross C. What are the element contained in B? The element contained in B is 2, 3, 5, 7. Cross C. C contain only one element, that is 2. The possible ordered pair, the first one is 2, 2. Next 3, 2. Next 5, 2. And the last one is 7, 2. So it is a value of B cross C. Now we write A cross C intersection of B cross C. Now we find the intersection of these two sets. Intersection means common. So what is the common ordered pair in both the sets A cross C and B cross C? Okay, you see first one is 1 comma 2. The ordered pair 1 comma 2 is not there in B cross C. How do you identify what is the common ordered pair? I take the common ordered pair. You see this 2 comma 2 is common in both the sets, and 3 comma 2. Next 4 comma 2 is there but is not there. 5 comma 2. Then one more is you identify, that is 7 comma 2. So the possible common order pair is 2 comma 2, 3 comma 2, 5 comma 2 and 7 comma 2. I put it is equation 2. After we write the second equation, you check from 1 also. From 1 and 2, you see the first possible order pair is 2 comma 2. Here also 2 comma 2. Next one 3 comma 2. Yes, is there 3 comma 2. 5 comma 2. 5 comma 2. 7 comma 2 and here also 7 comma 2. So how do they write the conclusion? From 1 and 2, LHS and RHS both have the same number of ordered pair, that is 1 2 3 4, and also the elements is also same. Therefore LHS and RHS are equal. Therefore the given statement is verified. So in this question, first step is to find the sets in roster form and then to check the values of LHS and RHS. An example 1.1. I already asked to the students. Many of the students are trying this sum, but 1 or 2 students has asked a doubt. So I explained this example sum also. It's also a very easy one. It's only one new word, that is n of. N of means the number of elements. So n of A cross B means the number of ordered pair. So that's only one new one. We already know this concept in the 9th standard. So okay, I remember. N means the number of elements. Is n of A cross B is equal to n of B cross A is equal to n of A. We don't read as a cross. Okay, it is the ordinary product, n of A into n of B. So this one is new in all the exercise problems. So I explained this example also. So there will be 3 questions are there. What are the questions? A and B is given. First of all, find the Cartesian product of A and B and B and E. The next one is A cross B is equal to B cross C. Both are equal or not. Suppose if it is not equal, we tell the reason why. And the third one, to show n of A cross B, that is the number of elements of A cross B is equal to n of B cross A is equal to n of A into n of B. So we say one by one. First of all, the given set is solution given. Directly the sets are in roster form. The value of A is 1 comma 3 comma 5 and the B set value is 2 comma 3. What we find first? A cross B and B cross C. So first we find A cross B. A, the value of A is 1 comma 3 comma 5 cross B, the value of B is 2 comma 3. The Cartesian product, the first possible order pair is 1 comma 2. Next one 1 comma 3. Wow. Next, after 1 the next element is 3. 3 comma 2. Next one 3 comma 3. Possible next order pair is 5 comma 2. 5 comma 2. After 5 comma 2 the next one is 5 comma 3. In the second one I check A cross B and B cross A both are equal or not. So I put it is equation 1. Actually it is a value of A cross B. Next we find in first one, the next question is B cross A. So next to find the Cartesian product of B and A. Now we find B cross A. The value of B is 2, 3 cross. The value of A is given is 1, 3, 5. The ordered pairs are 2, 1. Okay, always in the ordered pair, the first element lies in the first set, the second element lies in the second set. 2, 1. Next, 2, 3. Third one, 2, 5. Okay. Next possible order pair is after the number 2 is 3. 3, 1. Next 3, 3. The last one is 3, 5. It is a value of B cross A. Now I put it is the second equation. Okay, it is a value of B cross A. Now we check both A cross B and B cross A both are equal or not. If it is equal, we write the conclusion A cross B and B cross A equal. Suppose if it is not equal, we tell the reason also. So now we check. Now we see from 1 and 2 A cross B and B cross A values. We see the total number of ordered pair is same 1, 2, 3, 4, 5, 6. And here also 1, 2, 3, 4, 5, 6. The number of ordered pairs are same, but you see the ordered pair elements. First start from 1, 2, and here start from 2, 1. How we say how to conclude both are equal? Same number of ordered pair and also ordered pair elements are also same, but here differ. Not only the first ordered pair, we check anywhere. Suppose I will be take 3, 2. Okay, in first equation 3, 2 ordered pair is there. You see the ordered pair 3, 2 is not lies in the second set. So now I write the conclusion from 1 and 2. Okay, from 1 and 2, A cross B is not is equal to B cross A. It's not a verification sum. Now we check from 1 and 2, A cross B is not is equal to B cross A. So you tell any one of the reason. Now I tell the reason, since the first ordered pair in 1, 2 is not is equal to, in the second equation first order pair is 2, 1. At least you tell any one of the reason. Okay, in our question, then to find the reason also. So what is the reason both is not is equal? The ordered pair elements are interchanged. 1, 2 is there in the first equation, but in the second equation is 2, 1. Sir, we write this only one ordered pair. No, you write anywhere. Suppose I will take the last one. In the first equation, last one is 5, 3 ordered pair. In the second equation, the last ordered pair is 3, 5. Here 5, 3 and here 5, 3. So we tell any one of the reason. So first question answer will be over. That is, we find A cross B and B cross A both are equal or not. We identify A cross B and B cross A is both are not equal, but it is the same number of ordered pair, but the ordered pair elements are differ. Therefore A cross B is not is equal to B cross A. So second one answer is also finished. Now to find the number of ordered pair, the third one. Now we enter the order. First one A cross B, B cross A finished, and second one from 1 and 2 we come to the conclusion. So second one answer is also finished. Now the third one. In third one we find the number of elements. Okay, n of A cross B, n of B cross A, and n of A into n of B. So to find the number of elements, so n means no problem, is a number of elements. So n of A cross B, n of A cross B means the number of ordered pair in A cross B. What is the number of ordered pair in A cross B? The number of ordered pair in A cross B is a value of A cross B 1, 2, 3, 4, 5, 6. So that value is 6. Next one, n of B cross A. N of B cross A. That means the number of ordered pair in B cross A. The number of ordered pair in B cross A is also 1, 2, 3, 4, 5, 6. Next one, n of A into n of B. Now we write n of A. N of A means the number of elements in A. So how many number of elements in A? So A contains 3 elements only. A contains 3 elements. The elements are 1, 3, 5. So what is the value of n of A? The value of n of A is 3. Next, n of B. N of B means the number of elements in B. Now we check in B. B contains 2, 3. How many elements? Just 2 elements. So n of B value is 2. Now we multiply n of A into n of B. It's an ordinary multiplication. So n of A, the value of n of A is 3 into n of B value is 2. 3 2s are 6. Now we check n of A cross B value is 6. N of B cross A value is 6. N of A into n of B value is also 6. Therefore, n of A cross B is equal to n of B cross A is also is equal to n of A into n of B. Okay, n means the number of elements. Okay, this int multiplication symbol is not a Cartesian product symbol because it is not a set alone. It is a n of A and n of B. N means number. So 3 2s are 6. So now we check n of A cross B, n of B cross A and n of A into n of B. All are is equal to 6. Okay, all the values should be is equal to 6. So we come to the conclusion all are equal is our third one to show all are equal. Now we verify all the values it should be is equal to 6, 6, 6 and whose product is also 6. So how to write the conclusion? Therefore, n of A cross B is equal to n of B cross A is equal to n of A into n of B is proved or is verified. Okay students, today we see some problems involving Cartesian products, a union and intersection also. So many students have replied very well. One or two students asked a question, I explained the example sum also. So in your home, you must try all the questions in our classwork note. If you write at least 1 or 2 times, there is no mistake in our exam. It's a very easy one. Obviously we see all sums are very easy one. Suppose we miss any one of the ordered pair, LHS and RHS is not both are equal. If we at least we miss any one of the ordered pair, LHS and RHS will not come. It's a very easy one if you work hard. So you must try all the sums without seeing the video or without seeing the book also. Just you write the question. On solution we start all the sums. You write one by one. If I have any doubt, the doubt is clarified. So in maths regarding, in each and every sum, we must write at least 1 or 2 times. If you write at least 1 or 2 times, so no step is doubted to you. And what is the next step? What is the next step? You clarify the answer. So you must try all the sums without seeing this video or without seeing the book. Just you write the question and we started the answer. If you start from solution and last one verify, if you have no doubt, you understand all the questions. Because in our exam pattern, 1 or 2 created question will be asked. Okay, this walking rule is very useful to you.